Hello there. So, earlier on today, I was in the debugging section, and then VLab was being very, very unhelpful and not connecting very well. Strangely enough, it is now working. I'm just assuming that everyone who is working from home at the moment went on their lunch break. And during their lunch break, my VLab magically came back again. So, I wanted to go through what I'd originally planned for the lecture in terms of debugging this program. I mean, the program is called debugthis.c, so it's obviously there to be debugged. So, the program is intended for debugging, doesn't compile first go. So this is where we got up to, and I was about to open it and then realized that my connection was not really working that well. It appears to be stable now. See, I'm scrolling back and forth, so I'm going to run with it and see how we go. So I was saying two types of errors: syntax errors, logical errors. Logical errors can happen in code that runs, in code that compiles. But the first thing we're going to do right now, if I go back to my slides, I've got so much stuff open right now. Anyway, is have a look at this and see what kind of errors we can find immediately. We're going to follow the kind of procedure that I had for syntax errors, at least, where we say we're only going to look at the first error or warning that comes up in our compilation, and we're going to assume that any other errors might be a side effect of that, so there's no point looking at them until we've had a good look at the first one. So I've got my code here, and this could be any kind of situation that you're in when you're coding, where you say, there's a problem with my code, I have a debug error, I want to find out what it is. So this is set up to actually have some debugging errors in it already. So if I DCC, debug this, and I attempt to write it to a program called debug, stuff's coming up. Right, so I've got some problems here. Let me just shrink this a little so it's not in the way. Realized also that that code is being covered up by my face. Alright, there we go. Let's go back to my terminal. And so I've got a lot of errors. I am not going to look at any of the errors except for the first one here. So here's my DCC command. Sometimes it's hard to find it. If you do find you're having trouble knowing exactly where you were, you can type in clear, as I did there. Clear, C-L-E-A-R, clears the terminal, and then I can run my debug command, and now I can scroll up to the clear, and there's a gap there, so I can see that I cleared that, and now I can see my most recent DCC call here. So lots of errors. I don't know how many there are. There's at least 5 or 6 errors there. I'm not going to bother looking at them. I know some of them might be easy, but I'm not going to bother looking at them because I'm going to see what the problems are. So first one here, line 17. So if we go back to the slides, what I was talking about, where are we? Syntax errors. Start with the first error. Subsequent errors might be an issue. And here was my kind of procedure that I was going to use. Look for a line number and a character. So they give me the column, and that will tell me what to look at first, and then sometimes that's enough. But also read the error message and see what that says. So first one, 17, column 17 in debugthis.c. When we start using multiple files, this might point you in different directions. Using the result of an assignment as a condition without parentheses. So this is referring to this statement here, exit equals 0. Place parentheses around the assignment to silence this warning. So if we wanted to, we'd have to put a second set of parentheses because it's in a while loop there. But maybe we don't want to silence that warning, because maybe if I look at this more closely, this is an issue. Note, use double equals to turn this assignment into an equality comparison. Okay, now we're getting a bit of information that we can use. We have an exit flag equal to 0, and we're testing if it was equal to 0. Except if we don't test if it's equal to 0, but we make it 0, then we're in a situation where we're changing a variable at the point we wanted to find out what it was. So let's put a double equals there, because I'm pretty sure we were only meant to check whether we were going to exit or not. So this is one of those loops that goes forever until at some point we will change the exit flag, and I can see the exit flag getting changed here. So let's save that recompile, and that warning should be gone. We'll have a look at whatever turns up next on the list. Well, hopefully that warning's gone. Hopefully we've fixed the issue. So, DCC here. Error. Expected parameter declarator. Printf, thank you for using GridDrawer. Have a nice day. There's nothing particularly strange about that line, but we may have to look closer and find out what's going on. If you're trying to call a function on the line there, be sure that you're calling it inside of curly braces within a function. Also check the function's header, blah blah blah, doesn't end in a semicolon. Alternatively, if you're trying to declare a function, be sure that each argument to the function is formatted as a data type followed by a variable name. Okay, if you're trying to call a function, we are trying to call a function. Printf, line 47. Let's go have a quick look. Line 47, printf, it's here, it's before the end of the program. Potentially okay. Let's go back to our slides. Think about this. Read the error message, try and interpret. Remember, the error message is from a program that reads code. It might not make sense initially. Sometimes in an expectation of something that's missing, or it's confusion based on something being incorrect syntax. So it is saying, if you're trying to call a function, be sure that you're calling it inside of curly braces within a function. So for me to call another function, it has to be inside a function. It has to be within curly braces. It has to be code that is capable of running. This looks like it is. So I've got a closing curly bracket here. If I highlight this, I can see what opened it. I don't see anything opening it. So the example is here. If I highlight this, this one gets highlighted. So it says, okay, this is the thing that opened that. So I've got this one here, and I'm not getting any highlight here. So this is where I'm starting to think, oh, I've got a bracketing issue then. Because this thing said, this should be okay if it's inside curly brackets, but it's thinking that it's not inside curly brackets. So maybe there's a problem. Let's have a look at the main curly brackets and see if this is being closed properly. And we get this. We get this highlight here that suggests to us that this is the end of the main, which means this is outside my program. So this is in my empty space where I might make new functions and stuff like that, but it's actually outside. And so we need to figure out, where have I maybe closed something too many times or something like that. So I look at my brackets in this program. One way to look at brackets is to look at where it opens and look at the indentation level of where it opens. This is indentation level 1 deep, which is 4 spaces here. And so if I hover over this, I should see something. Oh, that's not right. That's at the wrong level of indentation. That's 2 levels of indentation in. So there's something definitely wrong with this while loop where it opens and closes. Another key sort of indicator there's a problem here is I have 2 closing brackets at the same level of indentation with nothing in between them opening any brackets, which means something's wrong. One of these is in the wrong place. So if we look here, this while loop is right, this while loop is right. This thing appears to be closing that one, which doesn't make sense because it's at the wrong level of indentation. If I put it at the correct level of indentation, it makes it look like this while loop goes to here, and it doesn't do this other stuff of resetting these variables. So this while loop had this thing of resetting variables inside it. Maybe this is incorrect. I have a feeling, I'm going to delete that whole line that had that on it. That might have been my problem. So if I look at these brackets here now connected to that while loop, this might be the whole thing. Especially because this says reset all variables for the next run through. That kind of has an implication that we're going to be looping multiple times here. So I feel like that's correct for that to be in there. And now if I look at my main bracket there, it links up to the end. So the main at the end, if this is just a single function program, that seems to be correct. So I've caught something, and we've looked at an error message there that is a consequence of something rather than the actual error. So let us hop back in here and compile this again and see if that same error is still there. Ooh, no more errors. Okay, in this case, this means that my program at this point is syntactically correct. So my program, each time it loops, it will draw a square of asterisks that is sized based on the user input. So we can just have a look at this and see if it works. So it's called debug. Run that. Please enter the size of the grid you would like to make. If you would like to exit, please type 0. So let's not exit for now. Let's go 5. We're expecting this to be a 5 by 5 grid of stars. My program hasn't finished because I don't have another prompt, so it hasn't returned my main function, which means maybe I'm stuck in a loop. Let's press Control C and see what's happening. Execution was interrupted. Yes, this I knew because I interrupted it. Debug, this C was at line 29. Loop through the rows of the grid. For each row, loop through the columns, blah, blah, blah. Execution stopped. Exit was equal to 0, so the loop of doing it multiple times was still going. X was equal to 6, Y is equal to 0. Grid size was 5. Okay, so we're getting some information there. Let me hop back to my slides for a second. Okay. So compiler errors, what did we find? Extra brackets. Ooh! There's another one there that we didn't catch. Scanf was not pointing at a variable. Did I? I think that was an error that I'd accidentally corrected earlier in this file, but there was this issue here that was going to be in there for the test. We'll just leave it as it is. Okay. So now we're into testing. Now we're into trying to figure out whether we have logical errors or not. So we can test some of our code to make sure whether it's working or not. Easiest thing we can do, and we've just done this already, is run the code. And we've run the code and we've seen there's a problem. And if we can get the code running, we want to try different inputs to see different situations, see what happens. So maybe there's a way to make the code run, maybe there's a way to make the code break as well, so you can figure out which situations it is or isn't working on, and different inputs that we could use. So the other thing we need to know is we need to figure out which parts of the code are working. So we might want some information about what's going on. And as we do testing, we will often write code that is not necessarily useful for the final product. It's not outputting the asterisks that we want in a box, but instead it's code that we're writing just to see what's happening. So we could write the program that gives us a lot of information. We can also test specific things to see what's happening. I'm just trying to think what I had in my slides here. Alright. We know how it's meant to run. It's meant to print out a square of things. We know at the moment it is not printing out a square. So let's try to get some information for what's happening. We know that the program got as far as here, because it did the scanf. It definitely did. Please enter, and then we put something in, and then it stopped after that, which means it got somewhere, and we knew that it got into this loop at some point. I might put a comment in here. Have drawn Y rows. Have drawn X stars. So this will just allow us to remember what's happening inside our while loops. What I might do is I'm going to do some information gathering. I know that in these loops something's happening and it's stuck and it's never going again in those loops. I mean, a lot of you watching this video or looking at the code will be like, I know exactly what's wrong, but I don't really want to train you, in a sense, to just be able to magically pick up what's wrong. I want to train you in a process so that when you can't see what's wrong, you can go through and try to figure out what's wrong. So what's happening with these while loops is that they're going to run multiple times, but we don't know how many times they're running, and we don't know what information they have when they're running. So what we might do is start putting some of that information in. And again, this is what I was saying, is like, this stuff is stuff that we're not even going to necessarily use in our final product or anything like that, but it's something that's going to be kind of handy for us to know as it's running. I should point out, as an aside, as you get deeper into programming, you're going to kind of graduate past this method of debugging, or we can actually use things called interactive debuggers and stuff like that. We're not showing them just yet, but eventually you'll get to them. Okay, so I'm just saying that for people who are thinking about the future or who have used debugging programs before. Yeah, I know they exist, but we're keeping it reasonably simple for now. So we're keeping it within the code we've learned how to do. So I'm going to put a printf in here that says while loop running. And this is just going to tell me I've started the while loop. So it's going to be able to print out where I am in the program. Y is equal to, and I'll do %d, and I might put an end line after that, so these are going to go line after line. Y. So this way I'm going to be able to track the loop running and how many times it runs. And then for each row we're going to loop through. So I'm going to say, get me some information about this loop as well. X loop running, and X is now equal to something. So just this much information is going to be able to tell me how many times the loop ran and what its variables said as it ran. So if I know what its variables are, then I know which column, and which column and which row it was trying to draw when it got stuck in this infinite loop, or when it stopped running. We're not really sure which of those has happened, whether it's paused or whether it's running furiously. We'll know with this, because each loop will tell us whether it's running or not. So I'll save that, come across here, oops, I'm going to Control C out of that. That was me running it again without compiling it. I need to compile it before I can run it because I've made changes to the code. So I'm running my compile command again, and I'll run this. I'll do the same thing, just 5. Uh-oh. I'm assuming that that's actually spinning, and it's doing a lot. I'm scrolling up now. You can see here, I'm scrolling up. So that was running lots and lots and lots of times. It's quite likely that that was running millions of times in the time I left it to go there, because you know, your computer can do a lot of those operations per second. So the while loop was running, and at this point the X loop wasn't running at all. I don't know what's going on there. Let's fix the while loop first. I know that the while loop is running again and again and again, and the Y is equal to 0. So what am I thinking here? And I know a lot of people have probably looked at the video and going, we know what's happening. This is like the he's behind you thing. So you saw what was going on. You saw the dastardly villain sneaking up on me because I left it here for you to see. Y less than grid size. So we're going to do Y number of rows. But we never changed Y, which means it was never going to reach grid size. Y++ is possibly our issue here. Okay. I'm going to leave this testing stuff in here because we still might use it. At least it'll give us some information about what's happening. Let's go back in and see whether that worked or not. Compile that. Run that. Size 5 again. I mean, I could run different sizes. Let's do size 7 for the fun of it. Okay. The while loop is running at y equals 0. The x loop is running at x equals 0 through to 7. And those appear to be the stars it's printing out. Then the while loop is running at 1, 2, 3, 4, 5, 6. Interesting. This is a while loop inside a while loop. We were expecting the X loop to run that 7 times. Wait. 8 times, I guess. Seems like 8 there. I don't know how many times it's meant to run, but we're supposed to run that a certain number of times every time we ran the while loop. But the information we're getting here is that it ran once, and it didn't run the other times. I will show you if we just comment out these to see what exactly our program is doing at the moment. Let's have a quick. Oh, I was pressing the up arrow, but I can't do that. I'm going to do a 0. Type 0 to exit. Thank you for using GridDrawer. Have a nice day. Oh, that's nice. I'm going to compile this again without those error messages to see what we're getting. So I type 7. I'm getting a single row. Type 8, getting a single row. Type 3. Those numbers don't look right. I'm getting 4 asterisks there instead of 3. Okay, couple of issues there. Let's try to get multiple rows happening first. So we did notice here that the X loop ran the first time and then it never ran again. Let's have a look at what's going on here. X is less than or equal to grid size, print out the thing, X is equal to X plus 1, then it loops again. We've seen this before. I'm pretty sure we've seen this before, right? Let me, rather than pointing out the obvious, is think about the situation where if this wasn't obvious. Or there will be times, definitely, when this stuff is not as simple as this. Or if you haven't seen it yet, and I'm still managing to trick you with this, let's have a look at what X is here. I mean, I could have done X first, then Y, but we're looping through Y, then X. Okay, so we're going to look at what Y and X is in that one, and then this one, we're going to look at X, then Y. Slightly reversed, but should be okay either way, because we've got the labels on them. So this should tell us what both variables are doing, and then maybe we'll get some more information there. So I'll compile this. Did I just DCC that twice? No, I didn't. Okay, good. Size 5. The while loop is running. Y equals 0, X equals 0. That's good. That's how it should start. X loop is running. X equals 0. And the X increases while the Y stays the same. Then the Y loop is running. Y equals 1, X equals 6. Oh no! That's not what we wanted. X is meant to start at 0 each time. We're not resetting this. So X is a variable that we created here. And so this is something where I've done something with my program which maybe I shouldn't have done. I declared all my variables up here, and then I used them down in here. But what I did accidentally is I created this X equals 0 so far outside of the scope where it was going to exist that it thinks it's a variable that just lives for the entire scope of the program, which is not actually what I want it for. So what I'm going to do is I'm actually going to take out that declaration of X. And what I'm going to do is I'm going to use the X variable, set that to 0 as late. I'm going to declare it as late as possible before it needs to be used. So this is the first time it's tested. I'm declaring it just before that. Oh, actually, it's getting used up here. Change that printf. Put it just after I've created the X. But anyway, X equals 0. And then I'll loop through here, which should make this X equal to 0 every time. So let's compile that. Let's see how we go. I'll exit from this. Ooh, I've got some errors. That's okay. Sometimes we change things and we get errors. So if that happens, we're just going to sort of wind backwards and say, this is a syntax error. I'm going to treat this like a syntax error. Line 40, error, use of undeclared identifier X. X equals 0, reset X to 0 so that it can print another line. Debug this, line 40. Line 40 is here, X equals 0. So, what goes on inside the curly braces stays inside the curly braces. This curly braces here contains the X. X doesn't exist outside here. This is also the reset X to 0, which I don't need anymore because I'm creating X again every time at 0. So I don't need this at all. That's fine. If I look at this, I could just compile this again, but I can see X being used here again, and X is outside of the loop. I also have no idea why X equals Y plus 1. This is past Mark throwing things in for you to debug. This makes no sense at all. X shouldn't be relative to Y in particular in this example. There's no reason why X and Y should have a relationship to each other. One loops and then the other loops, and that's it. I think that this line isn't necessary. That was a risk as well. I just deleted a line of code. But knowing the context here, I'm pretty sure the x in here didn't need to be changed out there. We also have an x equals 0 here, reset variables. I don't think I need that either, because I know that my x is getting set to 0 there. So what I've done is I've said, okay, x was out of scope. It was like this expanded scope it didn't need. And I've just gone, all right, it's in here and it only exists where it's going to be used. And then everywhere else, we're going to remove any uses of it. So hopefully I haven't broken anything else there. But let's see. So I'm going to save that. Compile. Don't worry about those warnings. They are gedit. I think it was, that's to do with the autocomplete stuff that we've got in there. Okay, we're going to run this again. And let's do size 5 again. This is better. This is better. The while loop runs, and the x loop runs multiple times. The while loop runs again at 1, x gets set to 0, x counts up again. So that's reasonably good. Let me exit that and take out my diagnostic printing, basically. That's my stuff saying this is what's happening inside the program. So if we take out the stuff that's telling me all this extra information, we can see how the program's actually running. So let's compile that again, run it. Yeah, size 4 this time. Okay. Now we have another problem. We are probably, but I'm not going to bother counting these, we're probably printing out a decent number of these in order to make a square, but the square isn't happening because we don't have any end lines to shift it down to the next row when it finishes drawing one row. So I'll exit from that. Let's come back across to here and see what's missing from our loop. So for each row, loop through the columns. Then we looped through each of the columns, printing stuff out. So then at the end of each row, we want a new line to push it down to the next level. So I'm going to do a printf here that does a new line, and this should split the rows. So it'll start to try to draw it like a square. Let's try that again. Now it's 4 again. Okay, we've got 4 rows now. Are we good? Are we happy? Is it finished? Let's look a bit closer there. I think my rows are too long. It looks like I'm getting 5 stars in each row. So I'm going to exit from this, and I'm going to turn my diagnostic statements back on, and I should be getting the while loop running a certain number of times, the x loop running a certain number of times. Now I know that you can probably see what's going on here, but I want to show you how we would like try to read the information that we're getting out of this. So I'm going to compile that, run it again. Let's do 4 because 4 is easy to see. So while loop runs, there's 1, 2, 3, 4 batches here of it running. And then the x loop runs 1, 2, 3, 4, 5 times. X is equal to 0, 1, 2, 3, 4. 5 stars when it should only be drawing 4 stars. So we can see by looking at this really carefully that the x appears to have gone to a value higher than it should have, which is allowing the x loop to run one more time than it should have. So rather than me just sort of looking at the code and going, here's the problem, what I want to get us to is to the point where we can find the problems by looking at the information and getting more information about how the code runs. So these kinds of little print statements can tell you a lot about what's happening inside your loops. And so we can see this, and if we look at this comment here, have drawn x, which is x number of stars. So if I've drawn x stars, and this gets up to 4, then I've drawn 4 stars. So if I'm in here and I've drawn 4 stars, it means I'm about to draw a 5th star. And so there's a problem there. So I should never get up to grid size here. I should be 1 less than grid size. And these comments, like if you put these comments in your while loops, they help you to just sort of understand, this is how many times I've done this. So now I know where I'm up to. And then we have drawn X stars in this row. Whatever the value of X is after these brackets close is going to be the total number of stars that we've drawn. So if it was less than or equal to grid size, and then we added 1 to it, it was going to end up 5, and 5 was too high because we said we wanted to do it 4 times. So grid size is something we read in from our user here, and that's the numbers I've been typing in. Okay. So with this, I think that change should be getting us the right behavior. Let's turn off our print statements here, run it as normal, and see whether we're getting what we want to get out of this. Oh, I haven't exited. Compile that, run it again, and let's do 4. Hey, now I've got 4 rows, and each of those rows has 4 stars in it. So I think for the moment, I mean, I can test this more if I want to. Actually, let's test it. If we want to test this for other things, I'm going to put a -9 in here. What is this going to do if I give it a negative for a size? Like, negative size doesn't really exist. Not bad. Not bad. There's something about the way I wrote this code that made sure that it wasn't doing something weird for a negative number. I can put a very large number in there. It's printing out for a while, 1,000 times 1,000. So I just told it to print out 1,000,000 stars. So I'm really, I'm really taxing what my terminal is happy about drawing here. I'm gonna let that keep drawing in the background. But I think one of the main things I wanted to talk about, is it still going? It's still going, is finding out what your program is doing. So these kinds of print statements will give you heaps of extra information about what your program is doing, and you're not going to leave them in your final program because they don't make sense for the actual drawing of the square. It's still going. They don't make sense for the actual drawing of the square, but you will get some information about where your errors are. They will tell you a lot about your program. This was a trivial program where you could nearly look at it and see all the errors, but it's better to also know how you're going to get information for times when you can't see it easily. Let me go back to my slides here. Okay. So looking at how it's meant to be run, modifying the code to give useful information, these are the kinds of things we can do to find out what's going wrong. So I think this is the slide I wanted. When you're writing your program, when you're partway through and you're not sure whether it 100% works or not, you don't have to worry necessarily about whether it passes all the auto tests then and there. Because sometimes you pass the auto tests, but you don't know why, and then you pass other auto tests, and you also don't know why. And then when you're failing auto tests, because you don't know why, you don't know what to fix in your program. So the point at which things aren't doing what you want them to, that's when you need to actually go, okay, why isn't this working? What can I test? What kinds of things am I going to be able to change to get this to work? So that's what I want to say. When you can test different parts of your code, when you can figure out which bits are working, which bits aren't. So what we did originally was we figured out how far this thing had gotten into. So we knew when we did Control-C that we were inside this while loop. And then we tested inside this while loop because we trusted the code that was outside the while loop at that point. You may not trust it later when you do other testing, you find other issues, but it's kind of important to just go, okay, one issue at a time. You know, I had like lots of issues. So the line wasn't running, and then we sort of noticed that the X was running too many times. It was like, okay, later. Let's fix one thing at a time, which is get the multiple rows. And we can do that by finding out what our program is doing, by getting it to give us more information about what it's doing. So sometimes it's like this, or sometimes we could do other things, like I can add another printf here, just saying scanf finished. like, there's not much information there, but it's enough for me to say I got this far in my program. Or I can say here, I can say printf detected exit, just for me to be able to say this is where the code was. And so when my code crashes, I can look at the last things it tried to say and say this is where the program got to when it stopped running, or this is where it up to just before it went into that infinite loop or paused and that kind of thing. Okay, but you don't need these. You don't have to keep them in your code when you're going into production, as in like when you're submitting your final version. You probably want to remove these because these commented out things look like comments, and we don't really want them to confuse people. So we can remove these because we don't need them anymore. We've gotten a lot of good out of them, and we know that we fixed our program because we got more information about it. We narrowed down what was going wrong because we knew which loops were running when, that kind of thing. We also have a good theory of what was happening in our loops because we've said, okay, every time we're in our loop, this is the number of things we've done, and then we could tell that the numbers that we were actually outputting didn't match the theory of what we were trying to do. So when we start testing like that, when we start testing with this intention of finding the issue and fixing it, we can get a lot more out of it. Okay. Nope, that's onto characters. Yeah, that's where we're up to, and hopefully that gives you a little bit of a hand for what you want to do when you're sort of actively debugging things. All right, see you soon.